So let's move down here, and let's say we were given 2 comma negative 3, and the slope being negative 1/2. Well, since we have a point and we have a slope, we could easily put that into our point slope form and to then convert that into standard form. So our point slope form y, again y minus y sub 1 equals mx minus x of 1. So here just plug in our points. Y minus negative 3 equals our slope, negative 1/2, x minus 2. I'm going to distribute and move all the numbers to one side. So then x plus 3 equals negative 1/2 x plus 1. Move everything to one side. So this becomes, I'm just going to move everything to the side with a y. So I'm going to add 1/2 x minus 1 to both sides. So then y plus 1/2 x plus 2 must equal 0. Standard form also does not like fractions. So to get rid of the fraction, I'm just going to multiply everything by the denominator, which is 2. I'm going to take this, multiply everything by 2. So this becomes, and remember standard form is ax plus by plus c, so I want the x first, so I'm just going to move it around. X plus 2y plus 4 equals 0. Here we go. This is our standard form. Okay, so now let's talk about parallel and perpendicular lines. Parallel lines, let's move this up. Parallel lines have the exact same slope. So parallel means the same slope. Perpendicular lines are two lines that have the opposite inverse of each other. The slopes are opposite inverse. So perpendicular So for example, if the slope of, let's say the equation is y equals, let's say 6x plus 2. A perpendicular line could be y equals the opposite, so negative inverse 1 over 6x, and it doesn't matter if there's a plus or anything, we'll just say minus 3. Doesn't matter. The important part is the slope. So let's do a little problem with that. So let's say we are given a point, 2, 1, and we are given a line in standard form, 4x minus 2y minus 3 equals 0. And they want us to find the parallel, I'm going to write it as parallel and perpendicular, like that, parallel and perpendicular line crossing through the point 2, 1 with from this other line. So it is parallel and perpendicular to this line, and it crosses through the point 2, 1. So first things first, what we need to do is write the standard form in y-intercept form. I'm going to add 2y to both sides. 2y. 4x minus 3 equals 2y. Divide everything by 2. So then y equals 2x minus 3 halves. We really don't care about the 3 halves, but we definitely care that our slope equals 2. So now we can use that slope and do a parallel and perpendicular line. So now we know the parallel has to have the exact same slope. So the slope has to be 2. And then I'm just going to write it in y-intercept form. So y-intercept form, let's scoot this down here a little bit, some more. Y-intercept form, remember y minus y is 1 equals slope times x minus x of 1. So here we have y minus 2, not 2, it's 1. Y minus 1 equals the slope, which is 2 over x minus x1 or minus 2. This would be slope-intercept form. We want to write it in y equals mx plus b, so we'll just move the numbers around. So it comes 2x minus 4, add 1 to both sides, then y equals 2x minus 3. So this is the parallel line crossing through the point 2, 1. Now we want perpendicular line. Remember, perpendicular is the opposite inverse, so we're just going to use slope-intercept point slope form and turn that into slope-intercept form. So this is y minus 1 equals, so this is the parallel up here, equals not 2, we want perpendicular now, so we want the opposite inverse, which is negative 1/2 x minus 2. We're going to distribute and move everything to one side. So xy minus 1 equals negative 1/2 x plus 1. Add 1 to both sides. So y equals negative 1/2 x plus 2. And this is our perpendicular equivalent. Let's do another example, our last and final example here. Let's say we are given the point 3, 2 or 3, negative 2, and the equation x minus 4 equals 0. We want to find a parallel and perpendicular equivalent. Luckily for us, this is a vertical line, that is x equals 4. So it is actually a vertical line going up and down at 4. And we want it to cross at 3, 2. So remember, let's go to one of the graphs. So it's point 3, 2 and x equals 4. Okay. So x equals 4 and the point is 3, 2, 3, 2. It's easier now for us to graph this to see it visually. So if x equals 4, so 1, 2, 3, 4, it is here, up and down, like so. If I want a line that is parallel to that crosses the point 3, 2, so if I go find the point 3, 2, 1, 2, 3, up 2, right? Well, isn't something that's parallel, isn't that gonna be another vertical line that goes up and down? So x equals 3 is actually the answer to that. That is the parallel equivalent. If I want something that is perpendicular, well, isn't that just 90 degrees crossing through the point 32 and right there? So it's a horizontal, so our line becomes y equals 2. And this is our perpendicular equivalent. Okay, and that is all for today.